Hey guys, so we're going to now use Trig to help us find the missing sides in right triangles. Okay, and this should be a little review from geometry, just something we want to work on some more. So just refresher, let's just do one or two of these from the do now. Given the sides of this right triangle ABC, find the ratio of sine B, cosine B, and tan B. So remember we have so, ca, toa, right? Sine is opposite over adjacent, cosine adjacent over hypotenuse, tan opposite over adjacent. So now, a couple of things. Which side are we going to label opposite, adjacent, hypotenuse? Well, look at what angle we're working with. The sine of angle B, cosine of angle B, tan of angle B. So this is our angle. So the first thing I want to do is I want to label. So we have the hypotenuse is the longest side opposite the right angle. Good. We have the opposite is the side across from the angle we're talking about, so this is opposite. And then we have the side that's touching the angle is adjacent. So now we can just fill in. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so just a reminder how we do that. We'll skip 2, we'll go to number 3. Well, here we have a right triangle, and it's saying find the sine of theta, cosine, tan of theta. Well, here's theta. So a couple things now. We know that 5 is the hypotenuse. We know that 2 is the adjacent side. And the opposite, well, we don't have a number for over here, but we can use Pythagorean theorem, right? So we do x squared plus 2 squared equals 5 squared. So x squared plus 4 equals 25. Subtract 4 from each side. X squared equals 21. Take the square root. And that's it. X equals the square root of 21. And now we can use SOHCAHTOA to help us fill this in. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. Cool. So just a reminder about some things about trig. When you know the angle and you take the sine, cosine, and tan, it's a ratio. It's a fraction, right? But a fraction can be simplified to a decimal. Well, what is the sine of 32 degrees? So what we're going to do is we're going to get familiar again with our calculator. How do we take the sine of an angle in our calculator? Well, I don't see it anywhere here. But we click f of x. And we see sine, and don't worry about inverse sine and inverse cosine inverse term. Look at the top row for now. So sine of 32 degrees, sine, numbers, 32. Enter. It says round it to 4 decimal places, so 0.5299. Okay? And you guys can do the others as well. Real quick, cosine 65. There you go. And tan 49. Okay? Now, how do we find a side using trig? Okay, and our first step here is here's a triangle. I only know one side. A right triangle, I only know one side, but I have this angle, and now we can use trig to help us find a missing side. You might think at first Pythagorean theorem, missing side, right triangle. Well, you can't because you only have one side. So our steps are this. Label the parts of the triangle, and that means, opposite, adjacent, hypotenuse. So let's do that. So here's our angle, 30 degrees. That means BC is opposite. That means 4 is the hypotenuse. Okay? Step 2, choose the appropriate trig ratio. And what I mean by that is using SOHCAHTOA. So I'm going to write SOHCAHTOA again. And we're going to see what sides do we know. Well, opposite we're looking for, hypotenuse we're using, sine is the winner here. Okay? Step 3, substitute into trig ratio. So that means the sine of 30 degrees is going to equal opposite over hypotenuse. That's step 3. And finally, step 4, put the trig ratio over 1 cross multiply and solve. So that means put sine 30 over 1, cross multiply, and you get x equals 4 sine 30. 4 times the sine of 30. So we take our calculator. Here we go. And we're going to type 4 times the sine of 30 degrees. And there you go, 2. We get x equals 2. So this side here, BC, is 2. Okay, so I'm going to practice a couple with you guys, and then I'll leave the rest of the sheet for you guys to work on. For homework tonight, guys, I want you to do up to, for the whole thing, I want you to fill in the beginning of the lesson and then do up to number 8. Okay, and I'm going to do a couple with you guys up here. So you get, let's see, here's our angle. Step 1, label the sides. 5 is opposite, and across from the right angle, this is the hypotenuse. So the one we're not using AB. I'm going to write this again on this page. So here we go. We take a look and we say, I know the opposite, and I'm looking for the hypotenuse. Sine is the winner again. So sine of 20 equals 5 over x. Put it over 1, cross multiply and solve. You get x times the sine of 20 equals 5. Solve for x, so divide both sides by the sine of 20. So you get x equals 5 divided by sine 20. Right into the calculator. 5 divided by sine of 20. 14.61. It says round to the nearest tenth, so you get x equals 14.6. All right, let's do one more together. Here's the angle, 30. 10 is the hypotenuse because it's across from the right angle. X is adjacent because it's the side touching it that's not the hypotenuse. So what's the winner when we have adjacent and hypotenuse? Cosine. So cosine 30 equals adjacent over hypotenuse. Put it over 1, cross multiply, solve. X equals 10 times cosine 30. So right into the calculator, 10 times cosine 30. To the nearest tenth, 8.66 is 8.7. All right, so work on these on the bottom, and we'll practice more today. You only have to go up to number 8 right here.